Plastic is not just waste. It is dependency, it is a habit, and it is an infrastructure that is built around convenience. The plastic we see around all of us, it takes thousands of years for it to decompose and has been killing our planets and ecosystems since centuries. Every year, over 400 million metric tons of plastics are produced and less than 10% is recycled. What's sad is the rest ends up in landfills, oceans, or burned into the air we breathe. At the same time, invasive species like Bornara, or commonly known as Crofton's weed, are destroying native ecosystems, suppressing indigenous plant growth, reducing food for our wildlife, and affecting local ecosystems. And while the world searches for alternatives, most bioplastic rely on food-based feedstock like corn and potato starch. In a world where food insecurity is rising, using food for packaging is not the smartest move. We saw a gap, and engineers love gaps. Hence, we present to you Relief Plastic, a biodegradable bioplastic derived from that very Crofton weed, an invasive species found abundantly across Nepal and 40 plus countries. Instead of competing with food supply chains, we convert an ecological threat into a value added biodegradable material. We collaborate with local forest user committees to collect this very plant. It is cleaned, dried, pulverized, and processed through our unique and innovative techniques. The result is the biodegradable packaging material you see on my hand right now. Early lab tests show promising tensile strength and flexibility comparable to polyethylene alternatives. Nature made the polymer, we just optimized it. What makes Relief Plastic globally relevant is that Crofton's weed is not just a Nepal problem. It is an invasive species present across more than 40 countries worldwide. Our technology can be adapted to other invasive cellulose-rich plants. This enables decentralized production costs, local biomass sourcing, and a licensable model for a rapid replication across developing markets. Our pilot production capacity is of 250 kilograms per day, translating to approximately 80,000 kilograms annually. Our pricing is strategically positioned at 3.1 US dollars per kilogram. Traditionally, plastics range up to $2.75 per kilogram, while bioplastic alternatives are way expensive at 4.13 to 4.5 US dollars per kilogram. This allows us to be cost competitive while remaining fully biodegradable. At full pilot capacity, this generates approximately $300,000 in annual revenue. Our cost structure per kilogram or our unit economics can be explained as below. We have biomass sourcing at 20 cents, chemical inputs at 85 cents, utilities at 45 cents, labor at 35 cents, overhead cost at 50 cents, marketing and sales at 30 cents, administrative and fixed cost at 22 cents, and contingency adding up to 12 cents. This secures us a gross margin of 18% before taxes. Our estimated plant setup and capital investment is 150,000 US dollars with a projected payback period of 6 to 7 years. With product process optimization and scale expansion, margins are bound to improve significantly, and so will our revenue. And with the funding and mentorship from Hult Price, we aim to develop a pilot scale production, conduct industrial testing, and secure regulatory approvals while patenting our very own innovative technology. The global bioplastic market is projected to grow significantly over the next decade, driven by policy shifts, consumer awareness, and policy changes. Nepal imports most of its plastic raw materials. Our business models include three major revenue sources, including B2B supply of bioplastic pellets, partnerships with FMCG brands seeking sustainable alternatives, and government and NGO supported environmental programs. Aligning with 6 out of 17 sustainable development goals, we are solving three major global problems at once: plastic pollution, biodiversity protection, and food security. Having worked in nationally reputed labs and associated and certified with reputed organizations such as the World Bank Group, UNOPS, and UNEP, we are not just dreaming, but we are already making strides. We are finally a chemical engineering students from IOE Pulsar campus, and we understand materials at the very basic level. If chemical engineers don't fix plastic pollution, who else will? Plastic has dominated the last century, but the next generation of our materials should belong to materials that work with nature and not against it. With Crofton's weed, we are imagining our ecosystem where waste becomes a resource, innovation becomes innovation, and local communities become stakeholders. And this is our startup, Relief Plastic. Thank you, everyone.